In this video, we'll start with a quick overview of the basic syntax and constructs that are used. This will help to provide a base level understanding of the concepts involved. We'll be examining the advantages and pitfalls associated with this language, including common errors. And by the end of the course, you'll be equipped with all the tools, insights, and knowledge that you'll need to diagnose and resolve issues as they arise. Jython is an easy enough language to work with once you have familiarized yourself with its quirks, and we'll be making comparisons with other scripting languages to explore its key features.
In the previous workshop, we did look briefly at Jython Syntax by writing some simple code to test the Python script plugin that we installed for Notepad++. I thought though that at this point it would be helpful to go through some further high-level details about the Jython scripting language, its main features and its syntax. So to begin with, in the previous exercise we had a look at variable assignment, and we saw that we could create variables as needed just by entering a name for them. Now in Jython, variables can take any name providing that they begin with either a letter or an underscore character. You can't, for example, have a variable that begins with a numeric character. As mentioned though, we can create variables simply by entering a name for them and assigning them a value using an equals sign. So I could create a variable called a to store a value of 5, and a variable called b to store a value of 10. And I could then, for example, print the results of adding the two variable values together. If I were to save this script and then open a new text file to show the results in, I can then run the script by using the Python script menu here, and the results are just displayed. Now as you can see, the operation here has been performed in the manner that I would expect. It's taken the value of 5 that was assigned to the a variable, and it's added it to the value of 10 assigned to b. The reason that this has worked successfully though is due to the data types of the values that I assigned to these variables. As whole numbers were assigned to a and b in this example, they were both treated as integers for the add operation that sits on the print line. The main consideration here is that the data types of the variables that you use are determined by the values that you assign to them. I could, for example here, change the value assigned to b from being an integer value to being a string simply by wrapping it in quotation marks. If I were to save the script now and try and rerun it, you'll see that no results are shown here. I can get further information about the issue that I'm experiencing here by opening the Python script console. So I can do that again through the plugins Python script menu by choosing Show Console, and down here at the bottom of the console is the reason for the issue that I'm facing. I'm still using the plus operation to try and add the values of a and b together. But essentially I'm now trying to add a number to a string of text. This has resulted in a type error telling me that it's not able to add these two data types together. This sort of issue is something that will come up regularly in the scripts that you write, especially when you're not familiar with the Jython scripting language. Because the values that you assign to variables determine their data types, you need to be very careful to make sure that you're working with the type of data that you expect in order to get the results that you would expect. We can handle this by performing conversions between various data types using some inbuilt functions that we have access to. If I return to my script file, so one way I could fix this issue here is to convert the value of the b variable to an integer when the print line is run. And I can do that simply by wrapping the b variable inside of an int function. So over to here, I can write the word int, open my brackets, and just include the value of the b variable as a parameter, like so. When this print line is evaluated now, it will first convert variable b's value to be an integer, if it's able to, before then trying to add that to the value of the a variable. So if I save my script and rerun the test again from here, you can see that we get the same result as we saw before. Alternatively, in order to make sure that the data types for my two variables match here, instead of converting the value of b to be an integer, I could instead convert the value of a to be a string of text, but we would get a very different operation being performed. Again, though, we would do this in the same way. So I could wrap my a variable inside of an str function to convert it to a string. I'll just remove the int function from my b variable here. Again, if I save the script and test it, you see now that instead of adding the two values together, it has simply joined the two strings of text. The 5 that was stored against variable a has been joined onto the front of the 10 that was stored in variable b. Although in both cases here the same operation was performed on our variables, the add operation, the data types that the variables held fundamentally changed the behavior of the operation that we perform. This is something that you'll need to be aware of and need to be very careful of when you're working with Jython. Another thing to point out here, if I quickly tidy my script up, is that there is nothing to stop us from reusing the names that we've already used once in the script. So I could now copy the existing script down here and change the values of our a and b variables on these lower lines. What we'd effectively get now if we run the script is the operation being performed twice. The first time on two integers and the second time on two strings of text. And in this case, both results will end up being shown in this results file. This means that although variables have been assigned values previously, their data types can still change on the fly as scripts are executed. This is another area that you'll need to be careful to make sure that you're not changing the operations that you're performing if you're changing the data types of your variables. Another noticeable feature of Jython scripts is that they make extensive use of white space. One of the key principles of Jython is that it should be easy to read, and the use of white space assists with this. The idea is that code gets read a lot more often than it gets written, and so improving readability is something that you really ought to aspire to in the scripts that you write. Jython makes use of white space to indicate the use of code blocks. This essentially means that related items should be grouped together with the same level of indentation, and this is used in all sorts of constructs in the language. So if you are looping through a set of objects, if you are using an if statement to do some branching logic, if you're writing a function which is only executed at certain times, or in numerous other places, you'll find that the code that gets used needs to be indented using either space or tab characters. So for example here, if I wanted to restrict this script so that the print line only runs when a is smaller than b, for example, I could perform an if statement to do this test. The lines inside of that if statement should be indented then. So I could do this here by adding a new line to the script. I'll type if a is less than b and finish the line with a colon character, and I would then need to indent this line here. And my preference is to use 4 spaces for indentation because I think that this gives a good level of readability to the script itself. Now, as we can see, I've assigned a value of 5 to A and 10 to B, and so this condition should be met and the branch should execute. So if I save the script again here, we should actually end up with a result of 15 being shown. So this is all working correctly because I have correctly indented the code for my if statement. If I return to the script file though, and I remove this indentation, I'll save the script again and then rerun it, then I'm now expecting it to generate an error. And you can see that's exactly what's happened here. So you can see that we've generated now an indentation error. Our console here is expecting an indented block to follow on from the if line that I entered, and it didn't encounter any indentation. and so it wasn't able to execute successfully. I should point out here that there is no requirement to use 4 spaces, which is just my preferred method here. I could use, for example, 2 spaces for my indentation. If I were to save this and run the script again, this will now work. The key thing here is that you need to be consistent with your indentation. Within any given code block, all of the indented lines need to have the same level of indentation, and it's good practice to use the same level of indentation for all of your code blocks. This firstly makes scripts easier to read, but it also makes it far easier to troubleshoot problems that may occur due to spaces. If I were to return to my script here and split this into 2 print lines, perhaps just printing A and printing B, you'll see that this will work just fine when I come to run the script. It just prints the 2 values like so. But if I change the level of indentation on one of my lines, this will no longer work. And again, you see we have an indentation error. This time it's got an unexpected indent because I indented the second print line more than the first one. So the key thing here is to be consistent. Note that you can end a code block at any point simply by moving the cursor back to the left, as I've done here on line 7. If I were to have another print line, I'll just print the word end like so, then this is treated as if it's outside of our if statement now. So again, if I run the code, you can see that all 3 of those print lines work fine. Essentially, it's performed the test here on line 4 to check that A is less than B, and because that condition has returned a true result, it's then proceeded to execute all of the lines inside of that code block. After completing the execution of that code block, it's then stepped outside of the if statement here and continued to execute lines one after another from my script. Just to prove this concept, if I change the test that I'm doing here on line 4 so that the print lines on lines 5 and 6 only run if A is greater than B, what we should now find is only line 8 will execute here because A is not greater than B in this case. So again, if I just come and rerun the script, we can see that that's the case. So all of this is just driven through the use of indentation, indents and dedents, and the position of our lines relative to the left-hand margin here is determining exactly when these lines will execute. Now I actually have a few examples to show here to compare how Jython handles the use of code blocks with how other languages such as C# and Visual Basic handle the same concept. So I'll copy my example here and I'll just paste this into a new text file. And you see at the very top here I have an example written in C#. Now just to make this a bit easier to read, I'm going to apply some simple formatting using Notepad++ functionality. Unfortunately, I can only apply one set of language formatting at a time to this file, so I'll have to format each of my code snippets here in turn. But the first example we're going to look at here is a C# example. You can see that this first line here is how we might assign a value to a variable. We need to explain up front what type of variable it is we want to create. So in this example it said bool, which stands for boolean. And a boolean value is one that's true or false. So we're saying we want to create a variable here called condition, which is going to have a data type of boolean, and we're also assigning a value of true to this variable. We then have an if statement to test the condition variable, and that's listed here. The way that C# handles its code blocks is by using braces. So you can see that for both the if branch and the else branch of this statement, the specific lines themselves are wrapped in these braces. These braces indicate the positions of a code block, and so the lines that sit between these 2 braces will only execute when the specific conditions are met. The requirement here in C# to determine up front the type of data that we want to work with, and the requirement to use braces to indicate our code block positions, make C# a little bit less intuitive than Jython when it comes to these items. Even though this code is well formatted here as well, you can see that it's perhaps a little less easy to read than Jython code. If I then move on to looking at the Visual Basic example which we have underneath, and once again I'll toggle the formatting of this file so that it's formatted appropriately for Visual Basic here. So in this we're performing the same operation effectively. This first line here is creating a variable called condition, and it's assigning a data type to the variable of Boolean. Again, the syntax for doing this is a little different than what we saw for C# and what we've seen for Jython, but the logic of it is identical to what we've seen so far. We're creating a variable here, we're assigning it a data type, and then in the subsequent line this is where we assign it a value. Following this, we then have an if statement which is testing the value of that variable. Notice though that the syntax of the if statement is a little bit different than what we saw for C#. There are no braces indicating the start and end of our code block. This is again much more positional. In Visual Basic, the code block is indicated by the use of the then keyword at the end of our if statement, and the code block terminates when it encounters another keyword like else, elseif, or endif. For this reason, VB may be a little bit more readable than C# in the case of complex scripts, but it still requires us to understand the data types that we're working with up front, and it does still have superfluous details that are not necessarily required to capture the process that we want to undertake. And it's here that Python, or more specifically for us, Jython, really excel. So if I scroll down now, I have an example of this code snippet written in Jython now. So the first thing to notice about the Jython example here is that we've been able to achieve the same effect as we did with the other languages, but we're using fewer lines here. Notice that the condition variable is immediately available for use at the top of this code snippet. We didn't need to define the variable up front, and we didn't need to assign it a data type. Simply by assigning it a value of true, we've been able to control the data type that the variable is storing. Also then notice that the if statement is simpler than we had in the other languages as well. Referencing fewer specific commands here means that the whole code set becomes easier to read, and the idea is that you should be able to scan down this very quickly, understanding what it's doing more easily than you would with other languages. So I just wanted to finish this section off by looking at a slightly more complex Jython script, one that we're going to be working with later in the course, to talk about how these rules and how this syntax will aid us when it comes to reading the code that we encounter. So once again, I'll copy a script that I've already written into a new text file to show you this. Okay, so I have a script here that I've just pasted in, and essentially this script will allow you to retrieve a list of data load rules for each of the locations that you've got registered in FDMEE. I just wanted to point out here really that although you may not be yet familiar with Jython scripting in general, and you aren't familiar with the specifics of this script, I just wanted to point out how careful naming of variables, careful use of comments, and proper indentation of code makes this significantly easier to read. So firstly, with comments, I can see that this script is broken up into three broad sections, one to do with an output file, one to do with getting locations, and one to do with getting rules for each location. While these comments aren't ideal, they certainly help to direct my attention to the relevant parts of the script and what they're doing. Also notice that the variable names that have been used give some indication of what they actually store. I have a variable here called PID, which is storing some sort of ID number. One called pName, which is storing a name of some sort. And again, if you look across all of the variables that are used in this script, each of them gives some indication of the values that they'll store and therefore the types of data that they'll store as well. Again, there's no hard and fast rule with this, and you should come up with a naming convention that works for you. But the more information you give yourself access to from the names of things, the better. Finally, without going through the script line by line to look at what it's doing, I also wanted to point out that the use of indentation makes this significantly easier to read. I can see that there is a while loop that started on line 27 here, for example. This is going to loop through a set of details performing an operation. I can then see that there is a second while loop which is listed on line 35. The second while loop listed here is indented, which makes it very clear to me that the second while loop sits inside of the first while loop. The code block for this first while loop covers everything that sits directly beneath line 27 up until the next dedented or non-indented line is encountered, which is line 43 down here. In the same way, I know that lines 36 through to 39 are included inside the second while loop, but the second while loop is terminated by the reference here on line 41. So again, without going through the specifics of each of the lines in this script, the key thing to point out here is that the script is much more readable than if we had everything shunted over to the left. And this is one of the real purposes of the Jython scripting language, to make code more accessible and readable. We'll be going through everything that we've talked about here and more in a lot more detail in subsequent sections in the course, but hopefully this gives you a high-level overview of how Jython scripts look and feel and some of the key features that they make use of.